Hi everyone, and welcome back to our next lesson of statistics. And in this lesson we will still look at the box and whisker diagram, but we will comment on the skewness of data as well as the spread of data. Now in the previous lesson we looked at the spread, but now we are also going to learn what is the skewness of data. So basically skewness refers to, does it have a longer tail towards the front or the back, and there's a way that we can measure it. So let's have a look quickly. If we look at this first box and whisker diagram, and remember this is only the top part, I didn't draw in the number line, but we can easily see from this box and whisker that this is our Q2, and the distance from Q2 to our minimum value is the same distance from Q2 to our maximum value. So basically what we learned in our previous lesson, that it is evenly spread. The data is evenly spread. Now if we want to comment on the skewness, it basically means that our mean or the average, and remember the mean is the average, right, is equal to the median. Now if I make the mean a blue line, look very closely. So we calculate the average of our data, and that means our mean will be equal to our median. Now the black line was our Q2, but look, if we calculate the average, we will have the same answer. So when the mean is equal to the median, we say that it is symmetrically skewed. So we get a spread like this, almost like a little bell curve, a perfect bell curve here, okay? So that means again, and I'll show you on this example, if this is our bell curve, that is our median. That means our average will also be the same as our median. Then we have a symmetrically skewed distribution. Okay, got it? Okay, so don't forget, when the mean is equal to the median, our spread is symmetrical. Now in this next example, if we comment on the spread from the median, which is our Q2, can you see it's a longer distance towards our maximum value, right? So that means the data are spread a bit more from the median towards the maximum than it is from the median towards the front. So it means the values are more bunched together from the median towards the minimum value. So when we have this long kind of tail, right, you work out the mean or the average, you will see that the average is greater than the median. So basically once you calculate the mean, you will see that it is a value greater than our median. And when it is like that, we can also comment on the skewness, and we call this positively skewed because it's got a longer tail towards the maximum value. So the bell curve kind of changes to this shape. So if I put the mean into this bell curve here, then you will see that the mean is greater than our median. Okay, so basically I will write in here that this is our mean, and remember we can write the mean as an X with a line on top. And the same, what if it is symmetrical? Then our mean is exactly the same as our median. If it is positively skewed, our mean is greater than our median. So now let's go to our final box and whisker. If you look at this box and whisker and we want to comment on the spread, you can see that the distance from our Q2, which is our median, towards our minimum value is longer. So the data are spread wider from one another towards the minimum. And you can see from the median towards our maximum, the data are more bunched together. Okay, so basically the spread here, we've got a wider spread towards the minimum. Now what if we want to comment on the skewness? Basically in this type of example here, and our mean, let me just put this in, our mean is smaller than our median. Okay, so the black line is our median and the blue one is our mean, and it is a value smaller because if we draw the number line here, we go from small to big, right? So this is a smaller value than that. And when the mean is less than the median, we call this negatively skewed. It's got a tail towards the minimum value. And when we look at the bell curve, it will have this type of shape, and we call this negatively skewed. So if I show you in this example again, so that is basically the blue line is our mean, the average, and we can write it with an X and a line, and you can see that it is a value smaller than the median, because again we go from small to big, and when the mean is less than our median, it is negatively skewed. Okay, got it? So now we can comment on the spread and the skewness of a distribution. So don't forget that when the mean is equal to the median, we call this symmetrical distribution. When the mean is greater than the median, it is positively skewed, like this shape. And when the average or the mean is less than the median, it is negatively sloped. The tail is towards the minimum, like here. Okay, great. So let's go and look at an example. Now, in our previous lesson, we learned how to calculate the 5-point summary and draw a box and whisker. And now we are just going to throw in a couple of more questions, as we are going to comment on the skewness as well of the box and whisker. So I'll run you through this entire example and then see if you can understand it. And here we go. So now let us try an example. The mass of 9 grade 9 learners was recorded. Okay, so we recorded the weight of 9 grade 9 learners. So here we have 40, 42, 45, 48, 50, 56, 56, 58, 60. Now, as you can see, we already, we were nice enough to already put this in ascending order from small to big, because you have to do that, right? Now we want to calculate the average, and I'll run you through this entire process. So to calculate the average, and we say that the average is a x with a line on top, which is the mean. The average, another word for it, is the mean, and I'll write that at the top, MEAN. Okay, and to get the average, we are basically going to add all the data together. So we're going to say 40 plus 42 plus 45 plus 48 plus 50 plus 56. Now you can do this process once off on your calculator, but I'm just showing you exactly how this is done. So we divide it with, and now we divide it by how many data we have, and we said there's 9 grade 9 learners, so we are going to divide it by 9. And once we add everything together, let's quickly do that. So it's 40 plus 42 plus 45 plus 48 plus 50 plus 56 plus 56 again plus 58 plus 60, and we get an answer of 455. And then we're going to divide that by 9, and we get an average of 50,56 if we round it off to 2 decimals. So 50,56. Now that is our average mass. Now let's calculate the 5-point summary. Now we have to get the minimum value. So the minimum value in this example is 40. And the maximum value is also quite easy to see, which is 60. Now we have to calculate our Q2. Okay, now please remember this. This is an uneven amount of data. So what we basically do is we take the 9, we divide it by 2, we get 4,5, we round it off to 5, and that will be the 5th number. So 1, 2, 3, 4, 5, that 50, and I'll just circle it in red as well. There we go. That is the 50, and our Q2 is equal to 50, because an uneven amount of data always have 1 point or 1 number right in the middle. Now we want to go and calculate Q1. So if we want to calculate Q1, we want the middle of the first half. And if you went through the previous lesson, that means we don't include the median. So it's everything in front of the median. Now that is the true median. So we are going to look at 48, 45, 42, and 40. And then basically that's 1, 2, 3, 4 values. And then we simply just go and we say 4 divided by 2 equals 2. We're looking at the second as well as the third number. So the second and the third, and then we quickly do that calculation. We will say that will be 42 plus 45 divided by 2, and that will equal 2. And again, always make sure about this, and our answer will be 43,5. And I'll write that in. So right there in the middle we have 43,5. Now we go and do exactly the same for Q3. So here on the side, I simply write Q3 equals 2, and in our second half, we've got 1, 2, 3, 4 numbers, which is an even amount, and 4 divided by 2 is 2, and because it's an even amount, we look at the second and the third number from the middle, so it's the 1, 2, that's the second one, that's the third one, so 56 and 58, that's what I'm going to write here. So we're going to take the 56 plus 58, and we are going to divide it by 2, and our answer will be 57. So that is basically our Q3. And again, it's so important that you do these calculations correctly, because now you have your 5-point summary, and from this we are going to draw a box and whisker. Now let us see how we will go about doing this. So I simply go and I start by drawing in a number line. There we go. And then we are going to choose our intervals. We start at 40, we go all the way to 60. So let's make it steps of 2. Why not? So it's going to be about 10 of them. So I'm going to start at the minimum, which is 40. And then I'm just going to go every 2. So that will be 42. Then again, same amount of space, that will be 44. Same amount of space, that will be 46. Same amount of space, that will be 48. Same amount of space, and you have a ruler to measure it. I'm just going a bit freehand here. That's 50. Then it's 52. Then it's 54. And then it's 56, and I'm almost going to make it. Then it's 58. Let's just extend this line a little bit there, and then we have our 60. Okay, great. Now my steps kind of are not the same. It was wide spaces, then it gets all a bit cramped there at the end, but you have a ruler to measure it. I am just going to show you what it is supposed to look like. So now again, what we do is we go to our minimum value, which is 40, and with our other pen or pencil, we just show you that we go up there for our minimum. Our maximum is 60 right here at the end, so we just go up here as well, the same height as with our minimum. Then our next one is Q2, which is at 50 right there, and that is our median, so we go up the same height. There it is. Then Q1 is 43.5, which is just almost in the middle between 42 and 44, right? Okay, just a little bit less than 44, which is around there. And I can simply put this line in all the way to the same height. There we go. And then our last one is Q3, which is 57, which is in the middle of those two. And we simply go up the same height. There we go. Now from Q1 to Q3, we want to draw a rectangle. So here it goes, and we draw a line through that line there, all the way there. And then we go up to complete this rectangle, and all the way down, and there we go. And don't forget your median, which is in the middle. We want to draw that black line there. So basically those three lines indicate Q1, the median, and Q2. And don't forget now the tails towards the minimum and maximum. So this one starts in the middle of the rectangle and goes there, and we end it off with a little line like that. And right at the end of this rectangle, we do exactly the same, and we are done. Now, don't forget this, please, because sometimes these values don't show the exact value on the number line, so we have to go and write it in. So here at Q1, we have 43,5, so I need to write in that value, and it is 43,5. The Q2 is a 50 right there, and our Q3 is actually 57, so I need to write it in there. There we go. And our maximum is 60. Then here we are going to write, this is our minimum, this is our Q1, this is our Q2, this is Q3, and this last one is our maximum. And you have to include all this data. Now, is the data symmetrical, positively skewed, or negatively skewed? Now, when I look at this, it seems like the distance is the same that way as that way. So it is evenly spread. That's why when you go and look at the average, and the median, they are very close to one another, and we can almost say that the average is exactly the same as the median, except for the 0.56. It's a little bit bigger, so not so much that we are even going to comment about it. So we can say that the median is almost equal to the average. So this data will be, and I will write here, symmetrical. Okay, great. Because the average, and I'll write that in, the average is equal to the median. Okay, and don't worry about that 0.56. It's so close that we can say that they are equal, and therefore we have a symmetrical distribution. Sweet. And I hope you could understand this. If it was that our average was greater than our median, then we would have a positively skewed distribution. If our mean was less than our median, then we would have a negatively skewed distribution. Okay, great. See you again soon. Keep practicing. Bye. This is your host Richard T, and thank you for joining us. Please visit our website mathsa.co.za for free guided exam tutorials.